Our next session is the workshop session, the network monitoring and network management and monitoring workshop, which will be presented by Mr. Qazi Tahmeed from APNIC. We are expecting him to join us soon. Meanwhile, that we are waiting for Mr. Qazi Tahmeed to join, I kindly request our participants to write in the comment section where are they joined us from, which city, which country. So, and of course, if you have any questions, you can always raise your questions in the comment sections and also in the Q&A section of the Zoom app. We will make sure to raise your questions during the sessions. Welcome back, Mr. Tamheed. We are happy to have you. Yes, please, you can have the floor and go ahead. Thank you.
Okay. Thank you. Thank you, Mr. Mohibullah. Apologies for this misunderstanding at my side. I just was made a mistake about 30 minutes error and was wondering what's going on. So I joined in. Otherwise, it's a good thing that I joined in, because otherwise I would have joined in about 30 minutes later. And Alhamdulillah, all looks good. But thank you for this opportunity. Thank you for the session. This is about network monitoring and management. Before we start the session, we just quick introduction on my side. My name is Tahmeed. I am from Bangladesh. I have spent the last 20 years in ICT sector, and in those 20 years time, I have worked in 3 organizations, including APNIC. I have been working with APNIC a little over years now as community trainer, and previously I spent about 16.5 years in one organization, then 1.5 year, about year and a half in another organization, my second one. So yeah, my career started back in 2005. Started as a call center engineer, and then ended up working at NOC with infrastructure planning and operation. That's all about me. Sorry about that. So today, we will be going through a lot of topics, and I will somewhat try to fast pace it and also try to give you enough time to catch up and keep up with me. We will do this in 2 groups. One is we will go through all the necessary theory, and then we will dive into the lab, where we will be doing all individual hands-on activities. So the lab sessions will be all individual sessions. So as Mr. Mohibullah was mentioning, please register in the Academy website, because other than that, you will not be able to launch the lab. Okay. So the first hour and a half, we will consider for the theory, covering the theory, and after that, hour and a half for the lab session. Okay. So let me quickly share my screen. Is my screen visible?
Yes, it's visible.
Oh, okay. All right. Okay. So if you are new to our, just a quick housekeeping information before we start with the presentation itself. If you are new to our Academy site, please go to academy.apnic.net. We actually have 3 kinds of services over there. One is there are online courses. The second is there are virtual labs, and then there are webinars and all that. These online courses and the virtual labs, they are actually available 24/7, 365 days a year. So you can actually access it at your own convenience. There is just one catch, is that once you initiate a lab or initiate a course, it has to be completed within a certain period of time. In the middle of the course or in the middle of the lab, you can actually pause it, save it, and then initiate the session from where you have exited. But it will then again be saved only for 7 days. Okay. But then again, it is always available to you. You can actually run it multiple times as well. So please do check out our virtual lab and online courses. Then if you are not familiar, we also provide technical assistance service. All you have to do is email us at training@apnic.net requesting for that. Some of us, at least one of us will actually get back to you to extend our support, where we will not be getting into your infrastructure directly, whether it's a system infrastructure or network infrastructure, but we will be asking for various command outputs and various configuration and diagrams and various other informations. And based on that, try to guide you to a resolution. Okay. A few other things, please, we are actually very much available in our social media platforms. So please check out our social media platforms. We are in YouTube, we are in Twitter X, we are in LinkedIn, and there are others as well. Please do check us out over there, because we do like to keep ourselves updated in our social media platforms. Two other things. We do have a blog site, and every now and then you will find that some interesting topic regarding technology or policies coming up over there. So please do check that out as well. That is blog.apnic.net. The other thing is Orbit. That's our evolution of mailing list that actually incorporates various other social media integration, and it's very much interactive, and it has various target specific groups. You can join in one of those, follow in those. All you have to do is go to orbit.apnic.net. Yeah, that's that. That's our housekeeping information. With that said, let's jump straight into it. Regarding this course, we will be covering Introduction to Network Monitoring and Management. We will be covering some introduction about SNMP, the Simple Network Monitoring Protocol. Then we will be covering a little bit on RRD, Round Robin Database Tool, and some other tools as well. And then we will be looking into various log management solutions. That is absolutely imperative part of monitoring. Okay. So yeah, in this presentation, we will be looking into basic of network monitoring. What is network monitoring and management? What, why, and how we do monitor, and the same things about management, why, what, and how we manage. Then we will look into some of the best practices about network monitoring and management. We will learn about out-of-band management, various techniques and tools, and software as a service based monitoring and management services. Just a brief about it. Okay. Like I mentioned, there is a lot of content, so let's start. Before we do that, may I request for a few thumbs up that we are all good to go? You can actually put your thumbs up in the chat. All right. Thank you. Thank you. Let's move on. So when I started working in the industry back in 2005, our infrastructure had like 40 routers, and we were using E1 and bit of fast Ethernet metro links and VSAT for satellite connectivity. At that time, Bangladesh didn't have any submarine cable. But when I left my first organization 16 and a half years later, we had like nearly 2,000 infrastructure, no, not 2,000, 1,500 infrastructure nodes. That's routers, switches, broadband network access devices. And these are all infrastructure nodes, okay? These are not end user customer premises equipments or anything as such. The 1,500 to 2,000 devices that I'm mentioning, that's all our own infrastructure. So as it grew, we saw the requirement of monitoring changes. All right. So it started with we were using one very simple SNMP monitoring tool where we used to log our downtimes, where we used to log our uptimes, where we used to log our packet losses and all that. This and the basic three aspects, uptime, downtime, and packet loss. But as we started to grow, we had to incorporate more parameters. We had to incorporate not only the uptimes, we had to find out correlations about uptimes in between multiple vendors. We had to incorporate service performances like DNS performance, like HTTP performances, like the time delay for, to some extent, the first byte latency as well. So as we expanded our infrastructure, as our customer bases started to grow, everything started to become more complex, okay? And nowadays, we have cloud, we have wireless, we have software as services of various kinds of software as services. We have VPNs, we have lots of firewall policies, infrastructure policies, and government policies all enforced on our infrastructure. Then we have mobile users, then we have IoT, and then we have VoIP. So it's a vast area of metrics that needs to be monitored. Okay, that's why nowadays monitoring is a bit more complex than what it was 10, 20 years ago. All right, and what you will eventually find out about it is that there is no one solution. There is no one software for you to have all your required services in place. Okay, so you kind of have to go broader, and you have to start working with multiple solutions, multiple softwares, because some softwares are good for something, others are good for some other aspects. So for system infrastructure, there are some softwares and tools that are very good for it, but those same softwares or services, they are not that much effective about network infrastructure. So you kind of have to merge. And then if you are interested in finding correlation, you kind of have to dive into log management, export all your logs from your basic monitoring platforms, and then start analyzing them. So this is what I have been discussing about, but let me just give you just an idea. This is your underlying infrastructure, okay? Whether this is a router, switch, and firewall infrastructure, I mean the network infrastructure, or you have servers and other things, other services running. So whatever that is. So it can be either system infrastructure or it can be your network infrastructure, okay? On top of that, you will have your monitoring softwares, okay, that will probably be using, in most likely case, probably will be use SNMP and ICMP. If not, you are probing for something very specific or some kind of agent-based solutions, okay? So these three parameters are there. You will be using either SNMP, then you will be using ICMP probes, or you will be use agent-based solutions, where the agents will be installed in your end devices. So in the case of routers and switches, that is not the case. In the case of servers and other platforms, you will be installing your agents. Those agents will be collecting required information from those devices, whether it's a virtual machine, whether it's a bare metal hardware, it doesn't matter. But at the end, then again, they will be using most likely SNMP, or they might be using some other protocols as well. So that's there, all right? Then you will have your log platforms, where the log platforms will be collecting logs from these monitoring solutions, okay? So on top of this, there will be your log analytics platforms, where you will be collecting all the information and pushing it to these upper layer log analyzers. From there, you will have a much more constructive, human readable format of what's been happening in the underlying infrastructure. So this is your ultimate visualization point. You have your middle layer where everything is being monitored. Then you have your actual underlying infrastructure, okay? So that's how it kind of works. So why do we monitor? Track resource utilizations, right? Then establish a baseline, like let's say that from our country, from Bangladesh to Singapore, the average latency via the submarine cable is about 45 to 50 milliseconds, okay? But we have to know that the baseline is in between 45 to 50 milliseconds. So we have to kind of figure out what that baseline is. And that's why we need to monitor. So we also have to figure out what is the baseline for Bangladesh to, not only just Singapore, Bangladesh to Hong Kong. We have to figure out the baseline about what is the lowest possible, what is the baseline about reaching to Australia or Europe, for that matter. Okay, so this is just one example where we have to figure out these baselines so that we can know that what is going wrong. So whatever deviation is there, we can actually identify that it's a deviation. Other than that, we do not know. Without the baseline, we actually do not know whether this is a deviation or this is a normal parameter. So if we do not know that our latency with Singapore is 50 milliseconds, and we are getting 60 milliseconds, we can very easily accept 60 milliseconds as a normal parameter, right? So we kind of have to do the benchmarking, the baselining of our infrastructure. So let's say another thing, give you an example. What is the second largest city in Afghanistan, apart from Kabul? I actually do not know.
So in terms of population, it's Kandahar, yeah, and
okay.
also, yeah.
All right. So let's say in between Kabul and Kandahar, you have like 200, 300 kilometers of distance, right? Let's assume. And your average latency to reach from Kabul to Kandahar should be around anywhere around, if it is a fiber optic backbone, that should be anywhere around less than 10 milliseconds. Once you initiate and start to benchmark, you will find that you may even find that it's actually 6 milliseconds or 8 milliseconds or maybe 6 milliseconds. Once you have this benchmark, if you have like 30 millisecond latency, you know that something is going wrong in between the communication channel of Kandahar and Kabul, right? But without knowing that your benchmark is 6 millisecond or 8 millisecond, you will never be able to identify that 30 millisecond, whether 30 millisecond is normal or not. So that's how important baselining or benchmarking is. And that's one of the first things that you are going to do once you start to monitor your infrastructure. Again, it can be service infrastructure, it can be your network infrastructure, okay? What are the things? Understand the performance metrics and do capacity planning. How I'm going to give you a very real life example from what I used to do. So we used to monitor latency using smoke ping, and we used to monitor our WAN link uplink capacities, and we used to correlate these two performances in a same graph. What we used to do is that we used to plot the aggregated usage of all our uplinks, and then we used to plot the graph, latency graph, international latency graph over that usage graph. And we used to try to figure out what is the breaking point where when we have like 60, 55, 52, 51 milliseconds of latency, and then at one point it just goes up. All right. And this is what we used to do for our capacity planning. That way, these are the kind of reports that we used to submit to our management, sharing that, all right, this is our 100 gig capacity, and this is at 93%. And you can see that there is a significant deviation in our latency changes and our performance degradation. So we kind of have to go for capacity upgrades, because while everyone will say that having more free capacity makes sense and makes your life easier, in real practice, in real world, you will never have enough capacity unless and until you are like tier 1 or tier 2 great carriers. You will never have enough capacity at your hand, and you will always be going through some form of congestion, whether it's in the uplink or in worst case situations, even in the access layer. So there is always that. That's the reality of it. So what we used to do is that we used to track all these changes, and we used to report to the management that this is the proof that that says that whatever is going on, whatever complaints you are getting, it's a cause of the capacity constraints that we are facing. So that's one way of dealing with it. Okay, so that's how you can actually monitor the performance. On the more basic aspects of it, you start to monitor latency. You start to monitor CPU utilization. So you know that in between Kabul and Kandahar, the latency is 8 milliseconds. You find 12 milliseconds, you have to look into the parameters, because 8 to 12 is not a big jump. But if you start to think in other form, 8 to 12 is actually 50% worse than your benchmark, right? So from 8 to 12, that's a 4 millisecond of increase. And that's a straight away 50% spike in your latency. Okay, so yeah, you kind of have to think in this form, that this is how things have to looked at. Okay. Then why we are monitoring, we have to find out the root causes. 8 millisecond to 12 millisecond, okay, fine. We know that something has gone wrong in between that link, and now we have to dig up what has actually gone wrong. And for that, we have to have enough logs, enough. It could be just one faulty transmitter. All right, that is probably running at a higher temperature than what it's supposed to be. So let's say that at one of the optical transceiver is instead of having a -8 dB laser reading, it is having minus 16 dB laser reading. That's all it takes for your latency to spike all the way up to 12 milliseconds straight from 8. All right. So you have to find out the root cause. And in order to find that out, you have to have these logs. You have to be monitoring various parameters, various hardware components, not just the logs that your devices are generating, but the devices, the hardwares themselves. What can you monitor? You can actually monitor your CPU, you can monitor your RAM, you can monitor your processes, you can monitor the threads, you can monitor your Ethernet network, your transmission errors, you can monitor your TCP/IP retransmission errors, you can monitor your optical lasers, you can monitor your temperatures of your transceivers, you can monitor temperature of your CPU, you can monitor temperature of your system as well. So the more you monitor, it becomes a bit more complex, but if something goes wrong, you will be able to figure out, it is highly likely that you will probably be able to figure out the actual root cause, what has gone wrong. All right. Then why you are monitoring? To track configuration changes. Okay. We used to keep backups of our configuration on a daily basis for some of the devices. For the other devices, we used to keep backup on a weekly basis. And in several cases, I have found myself in a situation where I had to scour through configuration backups for the past 3 months for auditing purpose. Okay. That's how important it is. If we didn't have a configuration backup of, let's say, about 12 years configuration backups, we even didn't have any specific clue as to why we are actually doing it. We knew that, all right, having it is a good option, so let's do it. But at a later stage, it proved that at one point I had to go through 12 months of configuration backup for figure out some auditing request. And at one point, in one case, I had to scour through configuration backups of 4 routers for the past 3 months. So it's a lot of work, but if I didn't have those configs with us, my life would have been even more complicated, and it would have been even more problematic. Okay, so it kind of helps you like that. All right. Then you log everything because you want to identify security threats. So to start with, just to give you an example, you start to monitor your SSH login atoms or your telnet login atoms, which I really do not prefer or recommend because telnets are insecure. So if you can switch to SSH, please do switch to SSH. And if you have to have telnet, please make sure that those sessions are protected by other means. Okay. But yeah, start to monitor your SSH attempts. How many attempts are there? How many attempts, failed attempts are there in your devices? You can actually start to monitor those. On a more advanced note, you can start to monitor certain failed replies from your DNS to assess whether you are going through any DDoS or not. Okay, so to start, you can start with monitoring your SSH login attempts or telnet login attempts. And on the advanced note, you can actually start to monitor your DNS failure messages there are various kinds of DNS failure messages, and you can start to map all of those in order to identify whether there are any DDoS that's been going on. Okay, so this is how you can actually assess your security threats. All right, moving on. What do we monitor? We already have discussed a lot of it, so I'm not gonna go through all of this. We do monitor hardware. We do monitor services. Services means your DNS, DHCP, web servers, your MySQL or SQL or Oracle databases, or whatever applications that you are running, whether it's your mobile application, whether it's your just desktop application, doesn't matter. All right. And they can be all either on site or they can be in cloud. It's all about what you want to monitor, what you think you should be monitoring, what you think you have to monitor. All right. Then you can actually monitor for underlay versus overlay infrastructure. You can monitor your OSPF parameters, your OSPF logs, your OMPs, your EVPN and VXLANs. These are all your overlay services. Your IGP, OSPF, and ISS, these are all your underlay services, or your BGP. You can monitor all of that. Then you can actually monitor, these are your sources, all right? These are your probe points, what you can actually probe. It's not what, where you can actually probe. Then what you can probe for, you can probe for availability, that is uptime. You can probe for reliability, that is your jitter, that is your latency, that is your round trip. Latency refers to round trip time. RTT actually is round trip time, that's generally latency. And you can monitor your jitter, then you can monitor your capacity. As I have already discussed this, you can monitor your traffic pattern, your TCP session traffic, your UDP traffic, your overall traffic. You can monitor your port utilization. That is the most basic form of monitoring. Then you can monitor for your performance. You can monitor your CPU, your memory, your processes, your disk utilizations, all of that. You can, your temperatures, device temperatures, your transceiver temperatures, your fan speed, all of this and that. All right. Okay. Before I move on to, we do have two questions. We have one question is from Asanullah Omari. We have approximately 10 to 12 kilometer distance between organization and the ISP, but the latency is always around 40 to 46 milliseconds. So what will be the root cause? There could be multiple factors in place. The first question is whether this is a fiber optic link, and from that point, whether this is a multiplexed fiber optic link or a point-to-point fiber optic link. Okay. If it is a multiplex fiber optic link, there is a possibility that your latency, average access layer latency, probably will be around 5 to 10 milliseconds. If you are using ONU, ONT kind of devices, or if you are using media converters, that is your dark fiber connection, and you are still getting 10 to 12 millisecond latency, then there is something definitely wrong with the entire transmission media. You have to go step by step. You cannot just jump start and assume, because even in a 10-kilometer distance, a dark fiber latency should be around 1 millisecond only. The worst case, it should be only 1 millisecond, or maybe less than 1 millisecond. Okay. So if you are using media converter based connections, then 1 millisecond is your benchmark. If you are using ONU, ONT kind of solution, that is a FTTX kind of solution, then your latency should be around 10 to 15 millisecond, but not more than that. Anything above this is considered as a negative thing. So if you are having 40 to 46 millisecond, I cannot tell you what the root causes are, but I can safely say that if it is a fiber optic link, if it is a fiber optic link, then there is some underlying problem, either in the transmission media or there could be something else. Imtiaz bhai, please. He is
Uh,
from APNIC.
yes, so I just want to add about the latency. So if the latency is like different than the actual distance, so this is because of the mainly the fiber route, because 100 millisecond of the 100 kilometer fiber cable distance, it will add 1 millisecond. So if they have like accordingly a longer distance, because the fiber cannot be laid uh, along the shortest path, there is some like visibility, and uh, in when it was laid, depending on the circumstances. So this could be different than sometime we assume it, and if it remains that longer all the time, that's mean this is due to the fiber distance, and each device will add 1 millisecond in this case as well. And if they have like multiple routes, so maybe they can experience different latency between two endpoints. Yeah, thank you. Please continue.
Thank you, Imtiaz bhai. So that's, I hope that clarifies your concern. The other question is, again, the other thing about your latency, if you are using wireless, then 40 to 46 millisecond, even though it sounds a bit higher, depending on the wireless signal quality, this may be somewhat acceptable. But then again, you kind of have to check. If it is what Imtiaz bhai and I have mentioned, it's about fiber optic. If it is a wireless, but then again, it should not be more than 15 milliseconds, even in a multiplex wireless situation. All right. So there probably is some kind of underlying situation that you kind of have to go through. All right. Unfortunately, because of the time constraint, we do not have enough time to discuss all of this, and we do have a lot to discuss, and we have already spent 37 minutes. The second question is, which data collection protocol is generally preferred to you for detailed traffic visibility, SNMP or flow analytics, and why? Thank you, Majid, for this question. It's a very good question. The answer is, you kind of have to have all of it. You cannot have net flow being collected over SNMP, and you cannot just rely on your SNMP probe based data. If you want to actually do traffic analytics, you have to have net flow. So that's a different protocol completely from SNMP. So you will have SNMP, you will have net flow, you will have other protocols, you will have syslog as well. All right. So like I mentioned over here, what happened there? Every network is different, and no single system will solve your problems or meet all your requirements. So it's all about going through multiple sets of solutions based on your requirement. Okay. Then we have, I hope that clarifies your concern. All right, there is all right, we have another question. Does content, application, and other items filtering cause having higher latency in our internet access, or any packet drop from our network to the internet? Yes. If you are doing extensive content filtering, then your overall latency will spike. Okay. It's very difficult to say by to what extent, but you can safely say that if it is very finely tuned, you will probably end up having at least 10 to 50% spike in your from your benchmark. Okay, could even go all the way up to 25% spike in your benchmark. So if you are having like 50 millisecond latency, that's it as a benchmark. With content filtering being applied, you will probably end up seeing 62.5 or maybe 56, anywhere around 60 millisecond or 60 to 65 milliseconds. Okay. So yeah, that's that.
I'm sorry for interruption here, Mr. Tahmeed. I just wanted to say that we will collect these questions and will raise them during the Q&A session. So to stay to not lag behind the agenda, if possible, we'll answer the questions later, and we first go with the presentation, and during the Q&A session, then we'll raise the questions.
All right. Thank you so much. Thank you for that, because doing it at the end, that actually will help the entire session. So thank you so much about that. So how to monitor most common use technologies. We already discussed some of it. We have ping, we have SNMP. Within SNMP, we have polling, we have trap. We will discuss about it a little bit later. Then we have 6log, that's another protocol. We have CDP and LLDP, another different protocol. We have NetFlow, that's another different protocol. Then we have API, application interfaces, that's another different protocol. All right. So all of these are different protocols, and they have their individual performance, individual parameters, individual requirements, and individual deployment scenarios. But to give you an example, ping, SNMP, and syslog, they are a set of collective protocols that you will be using when you are going to start your own monitoring sessions. All right. So you will be needing ping, you will be needing SNMP, you will be needing syslog. All these three, these are the basic requirements to initiate a monitoring system. All right. And if you want to make it actually an effective monitoring system. All right. So you have your, like I mentioned earlier, there are these three layers, right? You can see that there is the source. Those are your underlying infrastructure. Then you have your collecting engines. All right. You have your SNMP polling, your metrics polling, your traps. Then you have your storage, where you are actually collecting all of these logs. That's your NMS, network monitoring solution or systems. And then you have your visualization. That could be part of the NMS, or it could be part of your advanced analytics, all right, depending on how you are doing it, right? From there, you will have the dashboard. It could be part of your NMS. It could be part of your advanced analytics platform, all right? CDP, NetFlow, and API, those are the more advanced ones, okay? Network management. Why do we manage? To ensure maximum efficiency and overall productivity of our infrastructure and resources, all right? We want to make sure that we are not doing a access layer in VLAN 1. We want to make sure that if we are hooking up 10 corporate customers, those could be small corporate like Soho, or could be more established larger enterprises. But we want to make sure that we will connect them using 10 different VLANs, all right? And not in all one VLAN, because we want to filter out we want to squeeze down the broadcast domain, okay? If you are not familiar with broadcast domain and collision domain, I strongly recommend you all to go into whatever documentation you find out, to study them because in terms of management, this is like step one to understand what is broadcast domain and what is collision domain. Okay, so please do try to figure out as much as about these two topics. Okay, in simple terms, in today's session, increasing the number of broadcast domain while keeping every broadcast domain at a very small size is good for your network. Okay, in the same way, increasing the number of your collision domain while keeping the size of each collision domain to a minimum is good for your network. That's your best practice. Okay, so that's why you want to do VLAN. One of the reasons to do VLAN is to cut short your broadcast domain size. All right, and you have to do management of your network in order to ensure maximum uptime and stable service to all those 10 customers. Because if one customer is generating broadcast, even though it will come to your switch, the other customers, unless and until the switch actually goes down, the other customers will not be able to see the effect of that broadcast. Okay, so you want to ensure a proper service to your customers. That's why you want to manage it and don't want to just leave it unmanaged and then end up pulling out your hair. Security and threat detection. It is impossible to do this step unless and until you are actually actively managing your infrastructure. Again, it doesn't matter whether it's a system infrastructure or your network infrastructure or both. But unless and until you are actively managing it and monitoring it, it is impossible to assess this step. All right, security and threat detection, it's not possible. Network upgrade and visibility, capacity planning, business planning, all of that, that's also not possible unless and until you are managing and monitoring both at the same time. All right. So if you are managing it, it's highly likely case that to some extent you will probably also be monitoring it, but it's absolutely necessary to do manage and monitor if you want to keep track of your underlying infrastructure resources. All right. So what we manage, we are going to manage our network resources, that is router, switch, firewalls, load balancers. What are the devices at there? Wi-Fi routers, access points. Oh no, let's follow those. They actually goes into the IoT sections. Then we have here our systems where we have our servers, we have our applications, we have our services. So the servers, then we have the daemons like the Bind, Apache, MySQL, Oracle, daemons like this. Then we have our other applications like HTTPS, HTTP, or our proxy services or things like that. Okay. Then we monitor our power system devices. Then we monitor our customer premises equipments. We could just simply be monitoring it using ICMP. In our case, from my own expertise, we were doing ICMP-based monitoring for our customer equipments. Okay? And we can be monitoring our storage as well. So yeah, and if we have like access control devices, cameras, fingerprint sensors, card sensors, biometrics, and all that, we can also monitor all of that. Okay, so depending on what you have. How to manage? Well, it's a chart. I'm not going to get into all of the details of it, but for management operations, you can see that we have SNMP, we have NetConf, we have XML, and we have HTTPS operations. So these are most of the common ones that you will end up using other than the other ones, because As you start to head into a more complex management and monitoring solution, many of it will actually come into play with more specifically HTTP, JSON, XML, Yang, all of these parameters, URIs and URLs. All of these will come into play, but at the beginning, you will be using more about SNMP, ping, netconf, and probably a bit of XML. All right. Best practices, and this is very important. You have to baseline your not network, your infrastructure behavior. All right. You have to have the benchmark in place to understand if anything is going wrong. Okay. Then you have to have, and this is all of these are equally important. You cannot just skip one and hope to have a very effective system within your organization. The first step is you baseline your infrastructure. The second step is you build up your escalation metrics. Means not just what you have to do, but how you are going to scale it, right? So if you have like a device failure message, what you are going to do about it? Who will be responsible to respond at which level? So the preliminary checks, all the preliminary checks, and then the subsequent escalation to the next level. You have to define these parameters. You do not have to have ISO-based certified systems in place. All you have to do is you have to write it out or type it out, whatever you do, probably to a flow diagram, and inform everyone about it, that this is what we are going to do if something is going wrong. All right. It's very important. Then you have to have your escalation metrics as a layered breakdown. So while planning your infrastructure, you also need to plan it as in a hierarchical model instead of a flatline infrastructure. If you have access layer, at least two layers, access and core and distribution, where core and distribution will be hooking up with all your external entities like IX, IS, upstream, satellites, and all of that, CDNs and everything. And your access will be connecting with your customers only. It is highly recommended to have this kind of two-layer infrastructure in place, and it is highly recommended to have your public servers in a separate zone than your internal servers. Unless and until you are very much constricted, at least try to segregate them using VLAN. If you physically cannot segregate them, like in our case, when we were running multiple VMs, we were running more than 120 VMs in our VM infrastructure, and we were having customer-facing services as well as our internal services. It was not possible or feasible for us from a commercial and operational standpoint, both from commercial and operational standpoint, to have separate infrastructure. So what we did is we segregated the entire logical part of it. So whatever internal services was there, they were running on a separate logical network, and all the public services were running on a separate logical network. They were connected to different routers as well. Complicated, but kind of necessary, okay? So you have to keep those in mind. Once you have that kind of layered hierarchical model, you will also be able to assess the impact if something goes down. And this is what has been, what is being mentioned here by layered breakdowns, okay? Implement high availability with failover options. I will give you stories from my own example, from my own experience. We had Edge internet edge, core, and access. Even when we had like 40 routers back in 2005, even then we had these 3 layers in our infrastructure. By the time I actually joined in that organization, it was already there in this model. It just grew from that. At one point, we were only running city-wise. There are 2 major cities in Bangladesh. The 2 of the largest cities in our country. One is Dhaka, the one is Chittagong. We were only having 1 distribution router in both of these cities, okay? But as we grew, we kind of incorporated multiple distribution routers in both Dhaka and Chittagong. At one point in one data center, we were having 2 distribution routers where in addition to 3 more distribution routers in place. So we had like 3 data centers in Dhaka, 2 data centers in Chittagong, each having nearly 6 to 8 distribution routers. But when I joined, there were only 2 or 3 distribution routers in the entire 40 routers, among the entire 40 routers. So you have to plan accordingly, all right? If you cannot have it in one go unless and until you are starting off with a very big budget, unless and until you are doing it in that way, growing it as you grow is the best feasible option for you, all right? In our case, we did it like this. Could be different from you, different for you, could be same for you, all right? So that's what it means. High availability, implementing high availability and failover options. Capacity planning and growth, I already have given you an example how we were using monitoring and management for our entire infrastructure capacity, right? Relating our latency, international latency spikes with our upstream utilizations and reporting it to the higher management, to the CXOs that, all right, these are the benchmarks. This is how things are going. This is when things are going wrong. This is why things are going wrong. Unless and until you give us the capacity, I surrender, I cannot do anything. Okay? Please don't go and say this to your CEO. May not be received positively, okay? Just giving you an example, all right? But yeah, you have to have enough transparent information to make your argument stand out, okay? Out of band, it's like having a infrastructure within that infrastructure. So you have your own infrastructure, then you will have another infrastructure, preferably logically separated from the actual customer, your actual production infrastructure, which will only carry your management traffic. So if you want to get access to your devices, you will use the, sorry about that, you will use that out-of-band management system, okay? And if you want to do your configuration changes, you will use that out-of-band management system. I'm not going to get into any more details other than this. Everything is there. The other thing is that in the presentation, you will find out that I am skipping out a lot of slides. But if you download the PDFs actually have a lot more slides, and you can actually look into it in your own time. That will be more helpful for you. We have tried to cover as much as possible because of the time format, all right? Techniques and tools, I already mentioned that there is SNMP and ICMP probing. Then there is agent-based monitoring where agents are being installed in your system. Internal and external monitoring, you can have your, if you have your traps configured, SNMP traps configured in your routers, that is kind of internal monitoring being reported to your NMS. And external monitoring is that you are constantly polling something, probing something to get some data, all right? Then you have centralized versus decentralized network management. I can safely say that we had 1, 2, 3, 4, 5. 5 monitoring, regional monitoring stations in our infrastructure. Because we covered our infrastructure was spread all over the country. We, based on the regional density, we had like 5 monitoring platforms being deployed for every region, and 2 being deployed in Dhaka, 1 in Chittagong, and 2 more in 2 different regions. Okay, so if you kind of have to consider all of this as your network or service infrastructure group. All right. SaaS-based monitoring and management. This is about your cloud monitoring. What tools are there? These are all same things, just you are using different tools. And services, you have Logic Monitor, New Relic, Alvik, and Statuscake. Those are your SaaS monitoring services. Anything? Not really. We have already discussed all of this. Now, this is a big list. I'm not going to get into it. Please do check it out, because it lists all of the monitoring tools. We will discuss some of these in the upcoming presentations, but these are the links. Please do check them out at your own convenience. Okay. But we will be covering some of the tools later on. Network monitoring, what next? Legacy way is SNMP get, SNMP trap, and RD. Probably one of the most effective ways as well. The modern way, if you have like really advanced infrastructure and monitoring services in place, then you can actually use APIs, model-driven telemetries. Those are gRPCs, time series databases directly being generated. Not directly being, the data are being generated from your devices being exported to your NMS. All right. For management, we have SNMP set, but SNMP set, even I didn't use this, not in a meaningful way. But you will most likely end up using netconf, resconf, or openconfig, any of these platforms. All right. So, any questions? We will take 3 minutes for questions on this presentation.
Of course, there's one question from Mr. Mohammadi about the latency again. He asks, what factors can increase latency in an enterprise network? Obviously, it has different factors from misconfigurations in the devices to, I think, some... yeah, you can also add on this, Mr. Tahmeed.
I'm sorry to say, Mr. Mohammadi, I cannot give you any specific answer about this, because if you have like wireless routers, your PCs, your mobile phones, your Ethernet links, your Wi-Fi links, your firewalls, if you are using MikroTik routers or your gateway routers, whatever those are, your Cisco routers, your uplink routers, as many devices as you may have, whether they are managed, whether they are unmanaged, every node is a point of failure, and every node is a point where something can go wrong. So latency can be affected by any of these devices. Just one of them can actually cause latency spike, like a broadcast in your infrastructure, in your LAN, will actually increase your latency. Like a faulty uplink switch port will increase your latency. Like your switch port has been misconfigured, so it's running in half duplex, it will increase your latency. Like your
presence of bottleneck, for example.
Yeah, exactly.
Yeah.
So it's very difficult to answer this question, but I can say this, that if you are having any problem in your LAN, enterprise LAN, the best way to address this is to start at the top and then start down, right?
Yeah.
Start to monitor,
Top-down approach.
check at every level, starting from right at the top, not at the bottom, because you will not be able to find it, find the root cause easily unless and until you really know everything about your infrastructure. So it's best to start at the top and then come down step by step, step by step, step by step. And then at the access layer, go switch by switch. So if you have like 10 switches, you start to assess each individual switch, not the whole 10 switches, okay? So approach it in this kind of structured way. That way you will, even though it will take you 7 days to figure it out, trust me, in any way other than this, you won't be able to figure it out in like a month, okay? So that's how difficult it is. Thank you for that.
Okay, so there's another question from Mr. Majid Khan, how we can monitor internet destinations latency based on TWAMP, or what is the solution to do so?
Let me give you a very simple solution. Just run a ICMP server. We used to run ping plotter, and just set some random well-established destinations. Let's say, pick some destination from Singapore, pick some destination from UAE, pick some destination from Frankfurt, or if that is a uplink for you, pick some destination from London, pick some destination from New York and California, Sydney, pick some destination from some of the major cities where you think your traffic is being communicating, and try to monitor those, and keep an eye on the latency spikes, the changes, the behaviors. All right, so that's how you do it. All right, there are plenty of cloud-based paid solutions where you can actually get this kind of visibility. But in APNIC, we actually do not discuss about anything that requires any financial involvement. So all our discussions are based on open source platforms, right? So yeah, but there are various cloud-based solutions as well. You can have a look into it if you are looking for any kind of paid solutions. But for the free solutions, you can set up smoke ping, and this is what we used to do. We used to use smoke ping to monitor Yahoo, Amazon, and various other well-known platforms. Some of the gaming servers as well, those which allowed us to ping regional gaming servers, because we do have a lot of gamers in our country as well. So that's that. I think we have another
Yes,
question.
there is another question from Mr. Ihsanullah Omari. He has asked about protocol or log servers recommendation for an enterprise network. I think you already mentioned about protocol that we need to use for enterprise networks, but yes, you can answer this.
Yeah, I am going to skip this question because we will be discussing it very shortly in the presentation.
Okay, sure, yes.
So yeah, we have any L2 or L3 loop can also pause. Yeah, that it's a response of your latency spike question in your enterprise network. Yeah, that can also be in some cases, but L2 or L3 loop probably will not give you a higher latency. Rather, it will end up being it will end up breaking your communication completely. Okay.
Yeah.
What is in-house solution? Please suggest free tool. Everything we are going to discuss from this point onward is open source based. And yeah, so without further delay, let's jump straight into SNMP fundamentals. We will quickly look into some of the SNMP, then we will quickly look into some of the tools as well. All right, we will not be going through the configuration details or the steps, as those will be covered in the lab. So we will just quickly discuss about the features. All right. So SNMP fundamentals. What happened to my screen? Is it visible? All right. Thank you. So what is SNMP? SNMP is Simple Network Management Protocol. We will be looking into the components, protocol commands, versions, some of the communities, packet captures. We will not be looking into that. Configuration examples. We will not be looking into that. Okay. Let's dive in. It's been with us like for ages. All right. It's one of the oldest resources that has been used. This is the application layer protocol. It uses UDP port 161 to probe your devices, and your responses will be given over UDP port 162. This is something you need to note, because when you're implementing any firewall or ACL or anything, any filter policies, and you're monitoring SNMP based, your monitoring solution is SNMP based, and you end up filtering UDP 161 and 162 because it's generating a lot of small packets, your entire monitoring system will actually collapse. So yeah, so SNMP uses UDP port 161 to generate the probe query for the information, and it receives all the information over UDP port 162. All right. What it does, detect issues and fault early, monitor devices, device throughput, remote configuration, and control using SNMP set. All right. And yeah, that's what components are there. There is a SNMP manager, there is an agent, there is a management information base, and there are the managed devices. So manager is your, generally speaking, your software, your monitoring software. That will be your SNMP server or something like that. If you are using a configuration in your router like SNMP community, blah, 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 this and that, that means that router using an SNMP agent. All right. If you are setting up a SNMP community and a password in your server, that SNMP is an agent of your server. Okay. So that's how the agent and the server relation works. Then you have your management information base. That is, we will briefly discuss about it later. So SNMP manager, it pulls devices to obtain information and alerts. It's a central software application. Like I mentioned, it's probably going to be your monitoring software itself. It has the option for email or SMS based triggers. Okay. And as I mentioned, polling happens over port UDP 161, unless and until you are changing it. So this is what it looks like. Your agent is on your router.
पैनलिस्ट के ये मदद है पैनलिस्ट के زنگ
نو هغه د دې په پښتو مشته کې ترسيږي اوس دا سره حقیقت دا ځای ته ولې د کوم ځای
ما لیدلې ده خو د اسم لیدلې سي پاس ده نور
ته څوک نه پرېږدي.
Thanks. So SNMP agent is a process that is running on an agent. So like I mentioned, in your router, in your switch, in your server, whatever you're configuring, and it will actually send the traps of your the feedbacks that will go over U162. As a response to the information is sent as a response to the polling, as I already mentioned. So there is nothing that is new that we haven't already discussed. So you're over here in this diagram, your NMS is your SNMP manager, okay? MIB, it's a hierarchical database. If you are familiar with tree or linked list, you can pretty much say that it is a reflection of that. So you have a big tree with a lot of information, right? It kind of looks like this. So it starts at the root, then it is standardized ISO 1, then it goes to organization 3, all the black ones I'm referring to, then it goes to Department of Defense. From there, it comes down to internet, and every step it is represented with a number, and these are represented represented in between by dots, okay? So 1.3.6.1. It goes on like this. And at the down level, at the bottom layer, you will start seeing all the actual information, like your system description, your host name, your temperatures, your optical readings, your whatever that can be monitored. It can be monitored using SNMP, okay? Whatever parameters can be changed in a device, it can be changed using SNMP set as well. So SNMP is that much comprehensive. It's just a bit, what would I say? It's a bit annoying to look at this numbers. Okay, sometimes it may even give you a headache. So don't be afraid about it. It's all about the structure. It requires a bit of practice and requires a bit of headhunting and some headaches. But if you are into it, you have a way to figure it out. All right. So yeah. Then in general, every device installs an MIB, that is MIB2, that is RFC 1213. It is as per the standard. There are various RFCs about defining every parameters of MIBs. Yeah. The bad part about this is every now and then you will come up with vendors who actually installs their own SNMP and MIBs, and they keep it as a proprietary one. They don't release the information, and that becomes a very big problem for you. So yeah, you kind of have to deal with it with your vendor, because you cannot just go on randomly and do a SNMP walk and figure out on your own what everything means. All right, you kind of have to get back with your vendor and ask them for the MIB. Managed devices controlled by an agent, SNMP information source, nothing that we haven't discussed. So what protocol commands are there? There is get next, and get bulk. They are similar except for its execution. Get, you will get only one type of information. Get next, all type the next similar information. So if you are checking for an interface, you will check for other interfaces. Get bulk, a bunch of data. So you can say it's a batch processing, okay? So you're processing, getting a bulk of information. But interesting thing is even with get bulk, every messages is gonna be responded over, it's all happening over 161 and 162 UDP, okay? It's nothing different in there. And everything is replied as a response and nothing else. So even if you are querying with get bulk, you will get the response as a response, not something else, right? Then you have set. That's that's what you are going to use if you want to change some parameters. So if you want to change some configuration parameters, that's the command you are going to use. Trap is a very special kind of response that will generated by the agent, all right, and sent to the SNMP manager. Okay, so trap will be generated by the agent and it will be sent to the SNMP manager. Okay, trap will not be generated by the manager or anywhere else. It will be generated by the agent and will be sent to the manager. Okay, information inform is another way of acknowledging everything. All right, so if you are using get, you will get an inform update. If you are responding, you will get an inform update. So it works like that. So this is how it works. Okay, it's an so you have your get request, your get response, get next request, get response. You have your trap, and you have your inform updates. All right. There are 3 versions. Every version has its own advantages over the other. Version 1 is the most simplest form, but if you are using anything, if you are having anything other than 1G traffic, anything more than 1G traffic, SNMP version 1 will not work because it cannot monitor 1 gig traffic effectively. Okay, but it's the most simplest implementation. It's very easy to implement. All you have to do is set up a community string and just roll it out. We used to do it in the beginning. Then we switched to SNMP version 3. We skipped the version 2 because we wanted a bit more control and security. SNMP version 2 actually gives you authentication options, which SNMP version 1 doesn't have. So SNMP version 1 comes with general security implementation and considerations, when SNMP version 3 gives you security and encryption. All right, so you can have your engine ID. That's one way of one layer of security. You have your authentication based on your MD5 and TA algorithms. Then you have your encryptions based on DES, PDS, or AES. So you will have all of that. Communities version 1 and version 2. This is basically, there are read-only communities, write-only communities, read-write communities. It will depend on how you are actually configuring your SNMP agent and what you want to do with it. So if you just want to poll it or generate traps from it, you just need a read-only community. If you want to do both read and configuration management, you will need your read-write. And for trap, it will only be used for trap. Okay. Yeah, one interesting note, community names are basically passwords. So consider them, you can very easily consider them as passwords. Very important note, never leave your community string as public or private or whatever the device has been shipped with. Please change it. Okay. That will be a very big security hole you will be leaving in your infrastructure. SNMP version 3 security levels. There are 3 levels: no private, auth, no private, auth, private. So no auth, no private doesn't give you any authentication or encryption. It kind of gives you only to set up the name, but it doesn't enable you to set a password. Auth, no private, it will give you authentication and username password verification, but it will not allow you to use encryption. Auth private will enable authentication, encryption with username and password parameters. So one of the key reasons why we actually switched to SNMP version 3, when we find out that SNMP version 1 cannot monitor anything, links. Right. So LibreNMS is one of those open source tools. So that's that with SNMP. We are now going to dig into some of the monitoring platforms. All right. And again, these are all open source platforms. So LibreNMS is one of them, and probably one of the most comprehensive ones available in the open source community. And it is probably one of the most kept updated ones in the open source community, along with Nagios and Zabbix as well. All right. So for your network infrastructure, it is probably one of the best tools. Then you have your Zabbix. That can also be used for your network and system infrastructure. Mind you, LibreNMS can also be used for your system infrastructure as well. I'm not saying that you cannot use it for that, but monitoring system infrastructure using LibreNMS over Nagios it will put you in a less advantageous position. So monitoring system infrastructure using Nagios will actually leverage you more than what you will get from LibreNMS. But again, LibreNMS, if you want to monitor granular parameters like TCP sessions, like your UDP sessions, your IP protocol, IPv6 protocol, your fan speed, your temperatures, your laser readings, and all of that, and you want to have them all in a dashboard kind of way, LibreNMS and Zabbix, they are probably the ones to go with. All right. So what it supports is actually a broad range of operating systems. It supports Linux, Unix, and network devices that goes with Cisco, Juniper, Broket, Foundry, HP. It will support MikroTik, and also many more. The data set is very rich. The advantage is every set of devices, they actually give you different kinds of information. What LibreNMS is capable of doing is that it will collect all the information and it will kind of standardize the dashboard for you. All right. So if you want to create a dashboard only for laser reading from your Juniper devices, from your OLTs, from your FTTX devices, from your transmission equipments, your MUX, multiplexers, you can have that. All right. So LibreNMS gives you that kind of flexibility. The other thing is you can actually write your own modules. It has a extensive module set, sets of modules in the community. It also comes with some extensive modules, and you will get a lot of help, but it also enables you to write your own modules if you are interested. All right. Let's see what can be mentioned here. So it actually has the auto discovery mechanism. So all you have to do is pre-configure your underlying infrastructure and either use CDP, FDP, LLDP, OSPF, BGP, SNMP, or ARP to discover the entire infrastructure. The only problem is that if you haven't done it properly, your underlying infrastructure configuration, you will end up adding your customer devices, all of them. So before you enable auto discovery, make sure that you know everything has been set accordingly. Otherwise, you will end up with 5,000 devices where only 500 is your own device, and you have 4,500 additional devices. That will actually kill your entire NFS. So yeah, it supports Unix and Linux agents. It allows you to grow horizontally. It means that you can actually have multiple LibreNMS servers deployed regionally and then correlate everything in one dashboard. that is possible. It has a very flexible and customizable alerting system. It can send notification over email, IRC, Slack, and over API. That means if you are using the paid version of WhatsApp, you will be able to push your notification over WhatsApp as well. Supports an API for managing, graphing, and retrieving data. Definitely. Traffic billing system. Yes, you can actually create a billing parameter using LibreNMS based on your utilization. So if you can integrate your LibreNMS API, you can do a API integration with your billing software. You can actually have your LibreNMS generate traffic base. Okay. What sort of third-party integration it can do? It can actually integrate NFSN data, that is NetFlow data. It can collect data. It can have smoking data. It can have rancid configuration data and oxidized data as well. Multiple authentication methods such as MySQL, HTTP, LDAP, Active Directory, Radius, and all that. Okay, so it's really comprehensive, but it's very easy to set up as well. We are not going to discuss about this LibreNMS versus Observium, other than the fact that Observium came first and LibreNMS is a fork. It sidestepped from Observium, and it's more community driven and more responsive than Observium community. Okay. LibreNMS architecture has the following components actually. So it has a web interface, API integrated API layer. So it can be probed using Nginx and light HTTPD. It has at the back end, it uses RRD. So it's a time series data storing system. For advanced databases, it can be incorporated using MySQL or MariaDB. For Polar and Discovery, it's mostly a cron-based polling. The most common setup. We briefly mentioned that you can actually have your LibreNMS in a distributed architecture and then collect all the information and generate the dashboard accordingly, okay?
I'm really sorry for the interruption, Mr. Tahmeed, because the workshop will end in maybe 40 minutes more, 50 minutes more. Okay. So I just wanted to give you a reminder because of the time and the practical labs maybe also. So we have time for that as well.
Okay. So let's quickly just go through the metrics. LibreNMS supports, it can monitor memory, processor, storage, temperature, voltage, fan speeds, interface traffics and statistics, OS distribution, various OS operating system related parameters. It can have information based on your routing protocols, BGP, OSPF, ISIS. It can monitor your database and data structures or your web and other applications like DNS and things like that. It can actively monitor your IPv4, IPv6, TCP, and UDP statistics as well. All right. Storage is, like I mentioned, its basic is RRD database, but you can actually export these metrics to Graphite, InfluxDB, OpenTSDB, Prometheus, and more advanced ones from where you can actually run your analytics on those, all right? Correlation and analytics. But LibreNMS on its own will not be able to do all those correlation and analytics. We are not going to discuss all of this and move on to the next one. This is about RRD tool. We are not going to discuss a lot deal about it. So just few basics. It's a round robin database. What it does in the most simplest form, for certain period of time, it will keep all your data as is. So all the data that you have collected through monitoring, probing, polling, whatever that is, it will keep those data in a time series database. That means your x-axis will always represent time progression, and your y-axis will be representing the value that has been graphed. Okay. But after a certain period has passed, it will start to average everything. So after 7 days, it will start to average for 2 hours. After 1 month, it start to average for 6 to 8 hours. After 2 months or 3 months, it will start to average for a 1 day. That's why when you are monitoring graphs using RRD databases, you will see that there is a hourly, there is a weekly, there is a monthly, and there is a yearly graph. Everything has been averaged, and that's why you will see that your yearly graph will actually have lesser actual value than your hourly graphs. Okay, so that's how it works. The intervals can be set to 10 seconds to 30 seconds, 1 minute, or 5 minutes. Okay. We have already discussed this. In the x-axis, you will have time. In the y-axis, whatever data that are being plotted. Okay. Now we are going to discuss about smoke ping, because it is a very effective tool for monitoring latency and jitter. All right. So it has an excellent visualization feature. It can be deployed in a distributed way. So you can have a master slave setup. In our case, we did that. We had regional servers that were communicating with the primary one, and we were generating graph in the primary one. You do not have to do manual configuration in your regional servers. You only have to do the configuration in your master and tell the regional ones that how to communicate with the master server. Okay. Its data it is also using RRD, and it has been developed by the same person who actually developed RRD tool itself, and the MRTG software, and the smoking. All these 3 tools came from Toby Oetiker. And yeah, all the graphs. All right. Actually, the graph looks like this. So let me quickly, where's the pointer? So these gray areas, they are the deviation. All right. So those are the jitter. These are the jitter markers. Okay. That means it actually sends out multiple probes. Then it finds out the median. The median is being plotted in green, while everything else is being plotted in lighter shades of gray. So the more closer to the median, the values, they are the more darker ones. And if the jitter is high, you start to see spikes like this, all right? And if your latency is spiking, you will see latency spikes like this. Moving on, if you are looking at packet loss, it's a bit pinkish over here, but in reality, you will end up probably with a darker shade of red. Okay, but it will come as a horizontal bar in your graph. All right, and you can also actually select like only this portion and zoom into it and have a more detailed analysis of it. All right, it's very flexible. What is jitter? Jitter, It's actually exactly opposite of what traffic jam and good traffic means in actual road network. So no jitter means everything is running next to each other. All right. So much like if you are in a traffic jam, and jitter means that there is a significant amount of gaps in between each packet. So in actual network traffic, and I'm sorry for being so pedantic, in actual network traffic, after the FCS, there should be no gap. There should be no trailing zeros in between other than the next preamble. All right. So every every frame actually starts with a preamble, ends with an FCS, right? And there can be nothing in between, no trailing zeros in between two packets. If there are trailing zeros like here, okay, then that means the packets are not being delivered properly. That means your link is underutilized, your performance is compromised, your latency is abnormal, and your customers may not have noticed, but their overall service performance has degraded. So it means like that, okay? And what is latency? Latency is like you are from your home, you're going to your office and coming back immediately. The entire round trip, that is your latency, okay? Smoke ring configurations, not gonna look into all of this. Probes, different probes are available. Yes, there are several probes. FPing is for ping-based probes. You can actually probe DNS, DNS services. So if you want to monitor DNS service, you can use the DNS probe. FPing is for latency. EcoPing HTTP, EcoPing HTTPS, they are for monitoring your HTTP and HTTPS services, okay? So it's a very handy platform. Again, it's open source. Already discussed this, nothing. Yeah, the master-slave communication can have a secure encrypted communication using HMAC, MD5, or it can communicate over OSSL. That's an advantage, okay? Nagios is the other one I mentioned earlier. Generally, you will find that in most of the cases, it's being used for monitoring system infrastructure, but I know I have used it for monitoring network infrastructure as well as system and service infrastructure. So let me give you an example. What we used to do is that we had like 3 transmission carriers who were providing intercity transmission services. We used to monitor each transmission service carriers, group them, generate their performance, monthly performance data, and use it for their billing system, okay? We had to generate a report, monthly performance report that were attached when the bills are being processed, okay? And with that said, you can actually group multiple nodes under some term, okay? So that kind of grouping facility is there in Nagios. You can have host, you can have system, you can have network nodes, various kinds of groups, all right? So quickly moving on, monitoring network services, all kinds of services you can actually monitor, host resources, processors, disk usage, and all of that. Plugin interface to allow user-developed service monitoring methods. Sorry about that. You can have a hierarchical design in place, monitoring solution, so that you can actually know how to respond. Notifications, again, it can actually generate multiple kinds of notification. You can have email, API-based solutions. You can send out messages over Slack as well. It has automatic log file rotation facility and archiving facility. Backend actually it uses RRD. It has a web interface as well. All right. Viewing current network status, problems, and histories. Architecture is a server agent architecture. Again, like SNMP, it has a server, it has an agent. Or you can use ICMP-based polls, okay? Or you can simply use SNMP-based polls. Anything other than that? The agents are being installed in the server, as we have discussed it many times for now. That's what it looks like. So you have your database server components, your SNMP based network hardwares, your application interfaces. You have your Nagios daemon that communicates with all of these over different kinds of protocol. Then you have your plugins for visualizations and reporting. Then you have all your performance data being stored in your RRD. This is your Nagios infrastructure. This is your monitoring platform. This is your underlying infrastructure that you are monitoring, okay? This actually, you can check out this URL later on. This is an online demo. You can have this kind of graph, all right? Some terminologies, it has objects, that is anything. Like whatever you can monitor, it's an object. It has host or host groups. It has service or service groups. It has commands. It has contacts. All right, everything do have their own purposes. So what kind of objects you can have? You can have service and service groups. You can have host or host groups. You can have contacts or group of contacts. You can have commands. You can have time periods. You can have notification escalation. You can have notification dependencies. So all of these are considered as objects. We are not going to get into any of these. With that, how much time do we have? About 35 minutes or something
Yes,
like that?
we have 35 minutes, yes.
Okay. All right. 10 minutes for log management, okay? Yeah, please.
Sorry. Can you, Mohibullah, please clarify? This is the total time we have, not for the lab session. This is the total time left, or this is just for presentation session?
Yeah, the 35 minutes, 35 minutes is the total time we have for the whole workshop.
Yeah, so I would request to Qazi, like, can you please just wrap up the presentation and then we can proceed on to lab?
Yeah. All right, just a moment. So what we are going to do is we'll just quickly talk about where is the So about the log management, this is something that every system and network admin actually forgets, and this is something that is absolutely mandatory to find out the root cause of your infrastructure, okay? So whatever problem that you are having, you will probably end up finding it by analyzing the log. But in order to do a log assessment, you kind of have to streamline the log. So the general theme is every device will actually generate log in its own way, and every vendor will actually generate logs in their own way. To have a centralized log management system is to make sure that this kind of multiple formats, you can actually streamline it and bring out all the common factors and visualize it in a more human readable, meaningful way from which you can actually act upon, take actions, okay? So in order to have a log management system, there are processes that is collecting the log. You can have an agent-based solution, or you can simply just generate those logs and forward them directly to your server, okay? Then there is the agentless, that's what by generating it directly and setting it the source destination. You have your storage where you are going to store those logs. Then you have your searching mechanism where you will be searching for your required information. Then you will have your correlation, that's your analytics, okay? And you have your output, that's your dashboard, all right? In the output, you can actually have your raw logs as well. So it looks like this. You have your server, you have your local storage, and those send out the log to your centralized logging server. Yeah, you have your network device and your application. It looks like this, all right? This is what I wanted to show you before we move on to the lab. Every device will actually generate logs in a different, all right? And we will be using syslog, rsyslog. These are the ports, you can actually check it out. But logging levels, they actually range from 0, goes all the way to 7 at different level. Most important ones are 0, 1, 2. That's emergency, alert, critical, and error. Sometimes you will get warnings, and sometimes you will get 6 information or notice logs as well. Then there are facilities, various logging facilities, user level messages, mail systems, system daemons, various levels of logs, okay? Now, what log softwares are there? There was a question about what log softwares to use. In general, unless and until you want to do correlation and advanced analytics, you are better off with syslog ng or rsyslog. You can consider Graylog as well. Then there is Logstash, but that's more about going into the advanced area and analytics, okay? But to start with, you are better off with syslog ng or rsyslog, or you can also have a look into Graylog as well. But definitely Logstash, Grafana Loki, and log file navigators, they are excellent tools for you to have a more comprehensive approach to log management. With that said, I would like to close the presentation session at this point and move on to the lab. With the lab, let me just quickly open it up. I need you all to go to the Academy site and log in and go to the course material page. Actually, I need you to go to this link, Network Management and Monitoring Lab. Let me quickly paste this. How do I paste it to everyone?
I can share it with everyone
Yeah,
in the
I
chat.
have shared it with you.
Sure. Thank you.
Most welcome. So in order to go to this site, first you have to log in. Otherwise, it will take you to the login page. Okay. And then you have to, you should be able to see this at the first, as the first entry, the page. And all you have to do is click on the launch and then onto yes. All right. It will take a bit of time, and you have to have your pop-up allowed. Otherwise, your pop-up will block this window, and you will not be able to open the lab. Okay, you kind of have to allow pop-up. Takes a few minutes, build up. Please let us know if you are not seeing this page. I do not see any labs being initiated. All right, anyways, first note is that this is not just applicable for now. This lab can be accessed in your own time at your own convenience, okay? So 7 days later, tomorrow, 3 days later, 3 months later, you can actually access this link. It is always there. To start with the lab, it actually has 5 steps. The network management and monitoring, it actually is a very big topic. We actually run a more than a day workshop about it. And these labs, they tend to be more comprehensive, okay? But you can do all of this. We will focus on the first 3 for this lab session. So it's about configuring SNMP. Then we will, if time permits, we will do LibreNMS, and then we will go into smoke ping configuration, all right? If not, if we cannot do it, there is a high chance of that. All you have to do is read through these instructions, all right? And you will be able to complete this lab and have a active understanding of how to configure these softwares and how to enable a more comprehensive NMS solution in your own infrastructure, okay? So to start with, all you have to do is if you are new to our lab environment, these are the instructions. All you have to do is go next and go previous. In your resource, you have access to your resources, your routers, and, or your servers, and you have some additional info. All right. Your entire information set instructions, all your instructions are being shared here. Whatever you can see using that has a checkbox that mentions T, that's a command. So if I open up a terminal and just click on the T, it will auto paste this subsequent command to the terminal. If you want to copy it, so manually, you can copy this, but you cannot paste it directly. For that, you kind of have to go to select the Thunderbolt icon. From there, you have to type text, come down to type text. From there, you have to select type clipboard text. That will actually copy paste it. Sometimes it is this kind of copy paste is actually needed throughout the instruction, all right? And these checkboxes, they are there to give you an keep track of your own progress, right? So you keep track of your own progress by checking this. Once you have completed one step, you just check them and you know up to which point you have completed. All right. So the first step is to, where is that lab diagram? Yeah. So this is our lab diagram. We have 3 routers, we have 1 switch, and we have a host. All right. So yeah, the host is Ubuntu. We have an native Hyper-V switch. We have 2 Cisco router, that is router 1 and router 2, and the router 3 is Juniper virtual router. Okay. Keep track of that diagram, and you can have all these IP-based information listed here as well. Moving to the actual configuration, we will first come to the LibreNMS server, where we will apply this sudo apt get update command. And if we are asked for password, training is our password. Okay. Just a moment. I need to drink a bit of water. Hello, back. Thank you. So I'm just doing some basic things where I'm just installing the required softwares. These are basic Linux commands. By default, since we are not mentioning any path, SNMP, SNMP-D and everything, it will get, its configuration will come under the SNMP directory under etc folder, okay? So let's quickly check whether we have things good. File is there. Then let's see anything. MIBs, yeah, there is there. So we are this one is just simply adding a hash in front of the MIB command. All right. So now we have, you can see that previously it was an active line. We have now commented that out. Okay. No need. This is all right. So this is what it actually looks like. This is the actual configuration file, the entire configuration file. And we are going to add some configuration in here, right? So we are going to change the agent address directive. Currently it is set only on allow connections originating from the local computer to allow all connections on all interfaces. That's what we are going to do, okay? So we have to check what is mentioned here. We can see that it is only allowing 127.0.0.1 and IPv6:1, okay? So now we are going to change this and open it up. That's one way of doing it. The other way is just simply go nano etc snmp.conf. Right. Uh, so yeah, so we can also we might not have VR. Yeah, that's far easier. Agent address. There has to be a key, right? So you can simply just come into the file and modify it accordingly, okay? Instead of writing in the entire command. But you better be familiar with VI as well. Now that we have modified this, in order to allow 192.168.0.0/16 network to do SNMP queries, we have to add the community string training and following line to the access control section at the end of the file. So this is the same file we are still working on, okay? We just have to add a community string that will enable us to communicate with the devices and then allow the IP address range as well. this part, whatever is mentioned optional is actually optional. So we are going to skip that. We are going to skip this part as well. But since we have done some configuration changes and this is absolutely mandatory, we kind of have to restart of the systemctl services. So restarting the SNMPD daemon. Okay. First we have to stop, then we have to start, check the status, and then we have to start. Let's see if SNMP is listening. So we can see that there is 161, right? On IPv4 and 161 on IPv6. We do the netstat output, we can also see the same thing. It's UDP 161, UDP for v4, UDP 6, 161 for IPv6. Let's do a test. And this is SNMP walk. This is we manually trying to figure out what we can see. All right. So this is SNMP walk. This is the command. This is what you will use to issue all those get messages. Then you are mentioning version 2C. Then you are mentioning the community string in this. Then you are mentioning the destination IP address. And finally, you are piping it to less so that you don't end up with a, you end up with a scroll screen. Okay. So yeah, you can see that the kind of information that has been extracted using the SNMP walk command. Just the sheer volume of information you can see. Okay. In theory, a network device or a server, whatever hardware and software can be monitored if the vendor is actually allowing that, you will be able to monitor that using SNMP. And if that is configurable, you will be able to configure it using SNMP as well. So that's a general probe. Now you are going to do a probe for system parameter only. Okay. So you have your system, the time comes, name is actually system OR. You can see all the parameters. Let's use less. Okay. So you have this many system parameters. Then if you want to do an uptime only, you can have this uptime parameter pro query, and it will give you the uptime that it's up. It's been up for 2 minutes, 3 seconds. Okay. Now we are going to log into the Cisco router. So all you have to do is just click here. Username password has been given, APNIC training, and if you are being asked for enable password, that is lab config. As for Juniper, it's slightly different. Username is APNIC, password is training with T is being capital and A being at the rate. All right. So let's do quick. Yes, all you have to do is type it in. I will quickly go through this section. All you're doing here is getting into the router. After getting into the router, logging in, you're enabling the configuration mode using the config terminal. Interface within interface 1, you are defining description, IP address, and you are activating the interface using no shutdown. The same for interface gigabit 2, interface gigabit 3. Then you just exit out of the configuration syntax. Then you again get into the configuration mode and apply the SNMP configuration. And this is something that we need to discuss a little bit. Access list is to make sure that everyone is not being able to allow probe or allowed to probe your device. Okay. So first you create an access list that will mention from which source you want to allow the probe. Then within the SNMP server, you set up the community as training. Then it is a read-only mode. And then you apply the ACL that you just created. So this is a best practice. Please keep a note of that. Don't do this unless and until you know for sure that SNMP port 161 and 162 are being screened off in your infrastructure in some other way. Don't leave this line unprotected without ACL, okay? Let's ping. Okay, our server to we are now switching back to we just have configured router 1 and we are switching back to the Libre NMS where we will be installing a few things. First of all, and this is why the exclusive copy paste command comes handy. So you just do an install of NetTools. Then you just pump the interface. And this is what happens with you. Just simply try to paste it without using the method that I mentioned. You have to bring it up. Okay. Kind of have to. Sorry about that. Sometimes it does that. that has been. Now let's do a ping. Okay, so we can actually get access to the router. Now we are going to use SNMP. We use SNMP walk in the different setup, and now we are going to use SNMP walk again. This time from LibreNMS, we are trying to probe the router itself. Okay. You can see that a lot of people. For you, just to check how many interfaces are there. For how many interfaces are operating. What is this one? What is the admin status of the interfaces? So all you have to do is to figure out what you want to probe, what data set you want to have from this probe. This actually shows everything. So all you have to do is figure out what you want, or you can do a quick Google search, and that will give you more effective insights. All right, so that's SNMP.
Thank you so much, Mr. Tahmeed. I think we are finished with the workshop time, and duration is it's almost 5 p.m. in Afghanistan. So I think we will follow up with the rest of the lab maybe in future in other webinars, and we will be happy to have you to complete and also extend this workshop for the next webinars. Thank you so much for your presentation and your time.